AI systems rarely fail all at once. They drift, degrade, and expose new risks over time. In this lesson, we'll look at monitoring as the control tower that turns AI operations into measurable, auditable governance. So far, we've built the foundation layer by layer: the ISO 42001 management system, governance, risk, and accountability, governed solution architecture, and operational MLOps and LLMOps pipelines. Now we turn to monitoring and evaluation, where those controls become measurable evidence that AI systems remain trustworthy in production. Deployment is not the finish line. Once an AI system meets real users, real data, and changing conditions, its behavior can shift. Performance may drift, bias may emerge, latency may rise, and new security or policy risks may appear. In an AIMS, monitoring turns these signals into management control. It shows whether the system is operating within approved boundaries, and it gives teams triggers for escalation, correction, review, and improvement. This is where technical observability connects to ISO IEC 42001 expectations, operational control, performance evaluation, corrective action, and continual improvement. Think of monitoring, observability, and evaluation as three layers of operational confidence. Monitoring tells you when a known signal crosses a line, such as latency, error rate, drift, policy violations, or uptime. Observability helps you explain behavior you did not fully anticipate, using logs, traces, events, metadata, and data lineage. Evaluation asks the larger question: is the AI system still good enough, fair enough, robust enough, and useful enough for its intended purpose? Mature teams connect all three, so alerts lead to investigation. Investigation informs evaluation, and the evidence supports reviews, escalation, and audits. Governed AI monitoring is more than a single accuracy chart. It is a system of signals that shows whether the AI remains useful, safe, fair, reliable, and compliant. Model and data metrics reveal performance, drift, calibration, and pipeline health. Responsible AI measures surface bias, explainability gaps, overrides, appeals, and user concerns. Operational metrics track latency, availability, cost, and degradation. Security and control metrics expose policy violations, guardrail failures, prompt injection attempts, and emerging risks. The design principle is coverage. Every important obligation needs a measurable signal, an owner, and an escalation path. After deployment, evaluation becomes a continuous control, not a one-time gate. Track the metrics that match the task: accuracy, F1, AUC, precision and recall, or generation measures like groundedness and hallucination rate. Compare live production behavior against the validation baseline and the approved release criteria. Also, watch confidence, calibration, abstentions, fallback usage, and uncertainty signals, because degradation often appears there first. Then segment results by market, product, language, channel, customer type, and sensitive groups where appropriate. Good monitoring tells you not only whether performance changed, but where and for whom. Drift monitoring asks two related questions. Data drift asks, are the inputs changing? That could mean new feature ranges, more missing values, a schema change, a new language mix, or a different upstream source. Concept drift asks, does the same input now mean something different? This often appears as declining accuracy, weaker calibration, or delayed label checks. Teams may use tests such as PSI, KL divergence, Wasserstein distance, or embedding similarity against a reference baseline. Most importantly, severity must connect to action. Investigate, retrain, review, roll back, or suspend. Fairness monitoring asks a different question than accuracy monitoring: who is being helped and who may be harmed? A model can remain at 91% accuracy while one applicant segment sees rising false negatives, meaning qualified people are increasingly rejected. That harm can disappear in aggregate reporting. To catch it, teams track fairness measures such as parity, equal opportunity, approval variance, and false positive or false negative gaps. They also monitor complaints, appeals, overrides, adverse outcomes, and exclusion patterns. The key practice is stratified analysis, designed within privacy, legal, and impact assessment limits. LM observability has to follow the full interaction, not just server health. Capture the prompt, system instructions, retrieved context, tool calls, guardrail decisions, and final response as one trace. Then evaluate quality and risk: hallucination, groundedness, toxicity, jailbreaks, prompt injection, leakage, and policy compliance. For RAG systems, measure whether retrieved context was relevant, whether the answer used it, whether citations were covered, and how long retrieval took. The challenge is balancing visibility with privacy, so logs must be filtered, protected, and access controlled. In production, quality is not just model accuracy. It is also whether the service is fast, available, affordable, and predictable. Track latency percentiles, throughput, queue depth, timeouts, error rates, and dependency failures alongside GPU and CPU utilization, memory pressure, batching, and autoscaling. Connect those signals to cost: tokens, inference per transaction, vector database usage, retraining, and cloud spend. The key is to tie each metric back to risk tolerance and service levels, so teams know when to scale, degrade gracefully, or intervene. Eye safety monitoring asks more than, did the model answer correctly? It asks, did every control behave as intended? Track attempts to violate policy, outputs that were blocked, unsafe completions that slipped through, sensitive data detections, moderation events, and human overrides. Where possible, measure precision and recall, because a guardrail that blocks everything is unusable, and one that misses attacks is dangerous. Also, watch for bypass attempts, such as jailbreaks, prompt injection, unauthorized tool use, and prohibited data access. These signals should feed risk reviews, model tuning, policy updates, and executive reporting. Certification readiness is built through an evidence chain, not a last-minute document collection. Telemetry from AI systems feeds monitoring platforms, where logs, metrics, dashboards, and alerts show whether controls are operating. Those signals must connect back to the AMIS scope, system inventory, risk and impact assessments, policies, and control objectives. When an issue appears, the record should show who reviewed it, what decision was made, what remediation ticket was opened, and whether the fix was effective. Design this record's flow early so operational activity becomes audit-ready evidence by default. Thresholds are the bridge between monitoring and action. They define when drift, bias, latency, outages, security events, cost spikes, or guardrail failures become meaningful risk signals. From there, teams classify events as informational, warning, critical, or emergency based on likelihood, impact, and who may be affected. High-risk or uncertain outputs should trigger human review, especially when policy boundaries are crossed. Escalation needs named owners, response targets, required evidence, and clear communications. The goal is not more alerts. It is faster, accountable decisions proportional to potential harm. When a critical monitoring signal appears, the goal is controlled response, not panic. First, investigate the signal and choose the least disruptive safe option. Degraded service might mean switching to a fallback model, using rules, adding human review, limiting features, or refusing unsafe requests. If the issue is tied to a release, rollback criteria should tell teams when to restore a prior model, prompt, index, or configuration. If harm, security, compliance, or control risks are unacceptable, suspend service. Then document root cause, corrective action, validation, approvals, and lessons learned. Governance becomes real when monitoring creates evidence and evidence drives action. Track quality, drift, fairness, latency, cost, feedback, violations, and emerging risks. Preserve logs, metrics, alerts, incidents, reviews, and remediation for certification readiness. Define thresholds, escalation, rollback, suspension, and human review. Next, these signals feed security, threat management, and incident response. What we observe, we can improve.